This is Dr. Andy Yates, and this is the Incongruous channel. And what I'm doing right here is this is the first part of my presentation on energy is everything, the theory, right? Because it occurred to me, I've worked on the paranormal, the supernatural, the psychic, the religious, the spiritual, so on and so forth. And I wondered if there was like one thread that attached them all together. And I realized that there might be. Then I thought, well, I want to present this as some kind of a theory, like a paper you might present to scientists, and then it'll be peer reviewed and all this stuff. And then I thought, why do I want to present this to scientists for? Because if I put the word paranormal in there, they're not going to look at it anyway. And what do they know? They've got their own sort of directions, physics and cosmology and stuff like this. They haven't got the experience I've got looking at these things. So I'm like, okay, let's go for it. So what kind of subjects are we talking about? Well, we're talking about, I got some notes here, which I'm going to refer to. Oh, and I should mention these notes are actually kind of an older version of them are at the end of my book, Becoming a Motley Mongol, Amazon Kindle. Look it up, Dr. Andy Yates, you'll find it. And there's like 46 pages which detail this. But it's like 18 months old now, since I published it in June or July 2020. So this is a little bit more up to date. And of course, you move and you change and you update and you modernize. And then even change your theories, because then you realize new information comes in that says, you know what, you got that bit wrong. Or you might need to look at a different direction. But we're going to talk about basically what is energy, theories of energy. And then we'll look at the senses, the death itself, life after death. We'll look at spirits, near-death experiences, ghost entities, angels, demons, intuition, telepathy, psychometry, clairsense, auras, the soul, visitations. A little bit about reincarnation, because that's not really an area that I fully understand. Aliens and hyper-advanced life, tying that all together, and then just bring it all together at the end. So that's the idea. But because I usually stick at about somewhere less than 20 minutes, then this is probably going to be a series of little mini lectures. So this is going to be like part one of the energy is it, energy is everything presentation. Gotcha. Right. So back to my bits of paper here. And this, of course, as I said, this is pretty much what's in that book, Becoming a Motley Mongol, the last 46 pages. So if you buy the book, you get this for free. It's good, isn't it? Hey, when do you get things for free nowadays? All right. So let's start talking about what is energy, the theories of energy. Now, Einstein said, imagination is more important than knowledge. For knowledge is limited to all we now know and understand, while imagination embraces the whole world and all there ever will be to know and understand. Well, basically what he's saying is you've got to be open-minded. You've got to have the door always open. He was a theoretical physicist. I think that's how he's billed. And far be it from there being solid laws of science and stuff like this, there's always theoretical people looking outside those laws to see if they can be understood better, or to see if they can be extended, or even to see if they're correct. Because Einstein's theory of relativity has been kind of added to a bit. I mean, it was right, and it brought us a leap forward in understanding of time and space and the universe and so on. But there were some bits that weren't quite included in there, which have now been included as we move forward. So, okay. So that's that. So what my intention here is just to get your minds open and thinking. You sure as heck don't have to agree with everything I say. In fact, a lot of what I say may not be correct anyway. But I'm going to try and tie it all together into this single theory that might explain everything. That's what they do with theories. Now, for me to look at an energy theory, I have to kind of examine energy itself. So what is that kind of like in a scientific way? So there's two different types of energy, basically, at the layman's level, and that's potential energy and kinetic energy. Potential energy is any type of stored energy, which can be chemical, nuclear, gravitational, or mechanical, so like a stretched elastic band. Kinetic energy is found in movement. So atoms vibrate when they're hot, and so they also transmit sound waves. And electricity is in fact the movement of electrons between atoms. So it's kinetic. One important law or principle that we like at the moment is that energy cannot be created or destroyed. It can only be transformed, that is, radiated. I'm sorry, I'm looking at the dog. I've got the big dog in here with me. She's usually ever so quiet, but she's going to start dreaming. So if you hear any noises, it's the dog. She's wagging her tail right now while she's asleep. Bless her. Anyway, but you can't destroy it, you can't create it, which is kind of interesting, because what it means is that the energy that was created during the Big Bang is all there is. So you've got this one pot of energy that you can use for various different things, but you can never destroy it and you can never create it. It always radiates or conducts or transfers to some other kind of energy, and that's important. Now, let's look at some energy fields. We've got electromagnetic energy. I'm checking numbers here. Dog's tail. She's a happy dog. What's up with that? An electronic field can be considered a combination of electrical fields and magnetic charges, which when they move creates a magnetic field. So an electromagnetic field, of course, extends infinitely right out to the edges of the universe and beyond, if there's such a thing. Where you have any kind of moving electrical energy, you will always have magnetism. And usually a human being cannot detect an electromagnetic field. It's just not something we feel, right? There's something like another field, the Higgs field. Now, the Higgs field, interesting. It's theoretical, and it's throughout the universe again. Now, it's accompanied by a fundamental particle called the Higgs boson. You may have heard of this. And when they created it experimentally, it appeared, but it appeared so quickly that and decayed into other particles that they didn't actually have time to see it. But because they found the other things it decayed into, they said, well, this is real. So therefore the Higgs boson's proved. But here's where you get a clue. Here's a theory about something that they haven't seen, but they believe exists because they found the decaying products of that thing. And therefore, because they think there might be a Higgs boson, that means the Higgs field is accepted in theoretical physics. Not exactly solid, is it? And this is where physics goes, you see. So I think, well, my theory then sounds pretty much okay. All right. The thing about the Higgs field is that particles would travel at the speed of light if it were not for the Higgs field, because the Higgs field slows them down. A bit like you've seen, like in CSI, when they fire a bullet into water and it goes in and then it slows down. Well, that's how the Higgs field works. And a human being can't detect the Higgs field. You can't feel it right now, unless you're very special. There's another one called the 0 point field of energy, and this is discovered when a substance is at a temperature of 0, and I'm talking absolute 0 now, so minus something like 276 degrees Celsius or centigrade, 0 degrees Kelvin they call that. And at that point, because it's so cold, there should be no energy there. But there is. Because it doesn't disintegrate, because the energy that's holding it together doesn't stop and it just collapses. No, it's still got other stuff going on. And it still exhibits some vibrations. The lowest possible energy state something can get into is the 0 point field, the 0 point energy. But because the 0 point energy is universal, it's a massive, powerful field of energy, even though that energy is very lightly spread throughout the universe. You get the idea, right? And it's not human detectable. Well, of course, we should mention another one, and there's others, but this one, just for completeness, is dark energy. Dark energy. 68% of the stuff of the universe, so we're told, theorized to be one of the causes of the expansion of the universe. So it is the thing that is pushing the galaxies and whatever further apart. You see, the theory was that the universe would continue expanding from the kind of force of the Big Bang, and then, but of course you've got gravity trying to pull it back, yeah? So when you get, and eventually gravity would grab it and start to pull it back together. So you'd end up with a big bang, and then you'd end up with a big crunch when it all comes back together. But then they discovered, by looking at distant supernova, that actually that's not true, and that what's actually happening is it's expanding, and what's additionally happening is it's expanding at an increasing rate. So everything's getting further and further apart, and we in the universe are going to end up very much alone. Well, we won't be here then, but you know what I mean. Okay. So at that point, scientists had to take another look at Einstein's equations, like I said. Although Einstein took this massive step forward, it wasn't fully complete because he didn't have all this other knowledge, this modern stuff, looking through these telescopes, seeing these distant supernova, to modify his equations, because he was open-minded, right? And again, dark energy is currently not detectable. So it kind of seems that much of the scientific understanding is based on theory and speculation even. And once we get beyond basic kinetic and potential energy, which seems fairly solid as far as theory is concerned, you've got fields of energy which are invisible and undetectable, but the theories are accepted because they are a good explanation of what those things are and why they're there. And when we get into the quantum level, it becomes even more freaky and hard to understand. So, because when I was at school and college, I don't know if you are old enough to say this, but there were like models around the classroom which would be like ping pong balls on little sticks or springs or whatever, wires. And they would represent the molecules of substances, right? And these little ping pong balls were meant to represent atoms, which at one point, quite a bit back in time, was considered to be the smallest thing there could ever be, an atom. However, it's not. The atom is made up of other stuff. And the atoms are actually made up of a nucleus, which is made up of protons and neutrons, with an electron spinning around the outside. Well, that's kind of interesting, isn't it? Because not quite the solid thing, the solid atom we thought it was. And then you are going to ask, well, can we go lower than that? Can we look inside the nucleus, for example? Well, protons and neutrons are made up of quarks. What are quarks made of? We don't know. But we do know they're held together by gluons. And gluons are massless particles. And even that word, particle, is a misnomer. It made sense when it was first called that little ping pong balls were a particle, right? But you got to ask then, well, okay, it was a particle, but was it's made of smaller stuff, so therefore it's not a particle. The word particle is kind of like a container word to describe a group of other things, a group of stuff. But there is no stuff, because that stuff is made of smaller stuff, and that smaller stuff is made of even smaller stuff. You see what I mean? And that's what we're finding. Because there are plenty of... I study hypnosis. And hypnosis is a terrible name for what it is, because hypnos is the Greek sort of representative of sleep. Well, hypnosis is not sleep. That's exactly what it isn't. So you've got to think, well, if you could call it that, it's just a bad name. So particle is a bad name, but that's okay. Now, when we're on the search for the stuff of the universe, I'm keeping an eye on the time here, as distinct from it all being energy, maybe we could look at dark matter, because that's matter, isn't it? But again, and that's 27% of the stuff of the universe, but we don't know what it is. And it's dark because we can't see it. But we think it's there because we see its effect on other things, right? Research and speculation are going on currently. The best suggestion so far is that maybe it's made up of subatomic particles that we haven't discovered yet. But particles are just descriptors of energies and energy fields. So it's all energy anyway. So it's not matter, it's actually energy, clustered together in things, lumps we call matter. Right? So the impression so far is science is often not always hard fact. It contains unproven theories, speculations, assumptions, and so on and so forth. But that's good science, because you've got to, like Einstein said, you've got to keep reaching outside. You've got to look to extend your knowledge. You've got to keep going, because there's a whole universe full of knowledge. And if you just stay with what you already know, you don't go anywhere. So that must be the way to do it. Now, when I looked at this, there seemed to be two paths to acceptance, which we'll discuss. Yeah, we've probably got a couple of minutes here. What you can do is come up with a theory, right? And then look for experiential or experimental evidence that supports it and basically verifies it. Or you can look at phenomena. You can look at experimental or experiential evidence and then look for a theory that explains it. Do you get it? So you start off with a theory and then look for things that prove the theory is correct. Or you start off with phenomena and then look for theories that explain how the phenomena exists. So you get those two ideas. And of course, I've chosen the second one. And that's the way that is. Now, the scientific method relates to this, and I'll explain in part 2, coming up, how the scientific method basically works and how it's a process of peer review and stuff like that, and how it explains it. So this is part 1 of the energy is everything, energy is it theory. I'm Dr. Andy Yates. This is the Incongruous channel. Take care until you get a chance to look at part 2.